Start the recording. All right. I'm sorry. I forgot to restart the recording for last 5 minutes or 7 minutes or so. But whoever is missing this class for excuse reason or whatever reason, I just draw this sketch that you're seeing here, and I have these 4 sets of equation for projectile motion that we'll be using today. Okay. And the other thing that I'll be sharing now, and at the end of the class, I'll upload this as well, which is the PowerPoint, right? But I'm giving you time to take the notes. Let me know when you're done with the equations, and then we'll just simply go through quickly with the PowerPoint. And I do have a very simple math using these equations, okay? And you'll be expecting me uploading this video lecture today, along with any material, these like the PowerPoint slides or whatever, in Brightspace. I'll probably upload the homework number 3 by this weekend. Don't bother too much. I'll change the date of this homework submission to Tuesday, as I said, homework number 2. Okay, as I said, like whoever submitted the homework number 1, I already credited it. If you don't submit it, I credit it, right? Whoever submitted it, I did credit, right? I'm assuming, I forgot how many submissions. I'm assuming most of you are here, whoever submitted it here. Okay, so it's not like I won't be accepting the late submission for first one. I'd like to give you the opportunity to try to finish it by this weekend, okay? You'll be losing 10% point if you do that. After that, without my permission, I'll be accepting, because I don't want to allow that end of the semester. You're just doing all the homework, by doing whatever. It's not a proper way of learning, okay? So by this weekend, it's made it, just lose 10% point, homework number 1, okay? So that way you'll be up to speed, okay? So in other words, when I come on Monday class, I would like to say everybody submitted homework number 1, no exception, okay? And Tuesday homework number 2. Any question? That was good. All right, perfect. Everybody took the class note? It's fine? All right, and now quickly go through on the slides itself, right? This slide is, by the way, the summary of this book chapter. This comes from the book, your textbook, okay? So motion of a projectile and different applications that you're seeing here, like a jet is running, a missile can fly, there's thousands of applications, right? And we are dealing with this kinematic equation for projectile motion, okay, on this topic. All right, now obviously you're seeing some of the applications here. Is this a baseball player or is it football? Okay, is the Super Bowl today? Sunday. Okay, so the football player. Okay, the place where I come from is football is not soccer. We refer. Okay, here is football. Anyway, so the football player is obviously hitting a football. Okay, with some initial velocity, right? VA. Okay, and you are given with the angle. Anytime you're given with this. By the way, this is not the math though. I'm trying to give you a different scenario. Anytime you are given with the angle and the velocity, okay, those two things can be used to find what? The two components. You guys remember that? Vx and Vy. And this case is the initial velocity, right? So that's why you want to put a subscript 0. And then you would be asked so many things, right? As an example, you would be asked like, okay, what would be the velocity when it hits the football? I'm talking when it hits at point C. Now, obviously, this one line you are seeing actually is referred to these two things, right? The ball usually goes in the middle somewhere, right, in a plane. So it may be asked like, at certain distance from the ground, right? Say like 20 feet, right? Several things can be asked. As I said, like, what would be the velocity of the football, right? So you got to know one thing to find the another thing, right? So if you are given with the height, then, you'd be asked, Joe, you understand what I'm saying? So if you're given with the height, right, like this final height 20 feet, where the ball is flying, actually going through the goalpost, right? If you're given with the height, then you may be finding one of the unknown, like how long it takes for the ball to go, like the time. Maybe the time is unknown in that case. But if you're given with the time, say like, okay, it takes that much of time for the ball to fly here to here. By doing this stopwatch, you did that. Now your question could be, what would be the height then when it is crossing the goalpost, right? Do you understand? Different way it can be explained. But this is a practical example, okay? After doing this chapter, then you should be able to. Aline, you're good? You understand the practical example that I was referring? Okay. So there are some other practical example. It's all with the games, right? The basketball hoop, right? you're throwing out to some initial velocity. Okay, after some times, it'll gonna go to the to that. What does this thing call? Hope. Hope. Okay, so and again the question could be like two different ways: either how long it may take for the ball to go to that hoop, or if that much of time required, then what could be the hoop height. I mean, you understand what I'm saying? The location is the height y, and the time is the t. Okay, and this firefighter is like trying to what, trying to diminish the fire in certain height, right? So at what angle he has to put it, right? Something might come, right? What velocity of the water that needs to go through, right, through the hose, or if as long as you know the height, and the time usually is not that a matter. You may know the time as well, right? So those are the things important. Anyway, in design problem you can easily solve those, right, for sure. And those application just goes on. I mean, there's so many applications. The motion of a projectile, as you can see here, like this could be considered like a ball is thrown with certain velocity at certain angle, how far it will gonna thrown. In video games, if you're designing a video game, say like you might need to use those equations. Like when I was a kid, I used to play this kind of game, right, all the time. So the application could be endless, right? And then there is just these equations. Okay, everyone understand? So what you'd be expecting from me uploading these PowerPoints, interesting thing could be for you to review. I would be expecting from you to get the book. Okay, by next week I'd like to see everybody raise your hand. I do have the book, even it's a $5, $10 book. I remember there's this website called ABC Book or something. I used to buy books when I was a grad student, like 15 years ago or something, 16 years ago. I used to buy books for $3, $4. Nowadays it's not probably possible, right? It was super duper cheap at that time. And the old book, obviously, old version book. As I said, always remember, the classical subject. Whenever you are dealing with a classical subject like statics, dynamics, strength of materials, machine design, whatever you say, the material could vary in terms of the example problem, exercise problem, those things, but the theory is still the same. You understand? Unless if you're taking the advanced subject. Okay, in advanced subject, usually the application people teach. Anyways, any question with this PowerPoint? Everything's good? All right, so the final thing for our agenda today is the math, right? Everybody's waiting for that. All right, so this is the math that we'll be solving today. Let me get my class note, in case if you're wondering what I'm doing. All right. Just one second. For some reason, my class note didn't appear properly. Okay, it did come through. All right, so let's start with the problem. So it says here again. Here a person is shooting a ball or projectile from location A, right? So that person is shooting a ball from location A golf ball or something in that nature, maybe. Okay, so when this thing is shooting the ball, it is shooting at a certain speed, initial speed, I would say VA equal to 10 meter per second. Okay, the angle for the ball to travel is 30 degree initially. Okay, and the ball usually will gonna travel, go up to a height, the max height, and then it's gonna come to the ground, right? Obvious for the G. So several things can be asked here. First of all, the age value can be asked here, or it could be given. And when it hits at point C, the velocity, the final velocity could be asked here. Now, you may imagine how the final velocity should act here, right? So it would be a tangent like that, right? So that's your final velocity at C. You can put a VC as a subscript, doesn't matter. I'll just keep it as C. And then you'll have, just like before, the Vx and Vy, these two components, right? Everyone got it? All right. So, so when the ball is at point B, okay, when you're trying to find this value of the h though, right? What do you know about that? Like the velocity of y component, right? What do you know about the velocity of x component? So you have to use those 4 sets of equation that I just give it to you, okay? So that's your clue to solve the problem. Okay, let's see. So you got to find the horizontal distance it travels and the velocity at VC. So you got to find this. So they are asking this V as VC. You can say like, you know, instead of Vy, VCY. You can say like instead of Vx, VCX, right? So they're asking that, and they're saying like, okay, you find the horizontal distance, right? X value. Okay. But by the way, the h value can be found as well. Okay. Just to give you an idea. Any questions so far? Okay, let's start. So you are given with the velocity v, which is 10 meter per second, right? To find the x and y component of this velocity, so v a x at initial location, v a y. Everyone understand the subscript that I put? Okay, so the v a x would be this 10 multiplied what? Cos sin theta or sin tan theta? Cos 30 or sin 30? Is it cos? Cos 30 degree. Okay. And then VAY is 10 sin 30. Now, you see me dividing those two components. You got to understand why you are doing that. Remember those equations that you wrote? Everybody wrote those equations, right? Take a look on those equations. You do have this initial velocity in x and y components, right? So that's the reason you are doing it. All right. Then you are trying to find the velocity Vy, so like the final velocity, okay? So the way you can find it, Vy should be equal, I'm writing the generic equation first, okay? Remember that was the equation that I did write before? Everybody remember that? What is my A value here, by the way? This the A is negative g. There's the acceleration, right? Going downwards. So in other words, this A equal negative g. You can still put it over there, okay? So now that was my generic equation for sure. Now you can write this thing in terms of VCY equal V what? AY, right? Is the initial plus minus G multiplied T, right? Any questions so far? You may want to write the value now. Why did I find this equation? Remember the 4 equations that I wrote? To find the final velocity x component, to find the final velocity in y component, and to find the x location, to find the y location, right? We had all those things. Okay. If that's the case, then what are we going to do? Just simply plug the value. So I have this 10 sine 30 minus 9.81, you know, everything in SI unit, okay, multiplied time t. Now, if you'd like to put the unit, you want to put the unit here, meter per second, because that's your VCY. Okay, it's good so far? Okay, now one of the question is what? Let me rewrite the find here. So one of the question is find the x value, right? Where the ball or projectile will gonna hit on the ground again once it start to flying. So that's your x, right? So to find the x, everybody remember the equation? Everybody remember the equation, which is x equal x0 plus v0x multiplied t, right? So let me plug those values. So what is the x0 value, by the way? Where your coordinates start? And again, you can say anything, but you see your x-axis and y-axis, let me try to highlight that the different color. This is your y-axis, everybody agree? And this is your x-axis. Everybody agree? So the point it intersects, what would be the coordinate value? Is it 0, 0? So what is the value of the x0 or initial position at point A? 0, right? 0? A good job so far? All right, so you have a value of 0 plus, and you are trying to find the value of the x. So now, what is the initial velocity? 10? You guys remember? I don't know. Maybe I should be, I'm not getting proper response. Maybe I should be putting a subscript. So this is your xc, this is your xa, right? Now does it make sense, right? Okay, plus, okay, plus this v0o is like vax, right? I'm just putting it in terms of, you know what I'm saying? Okay, so can I rewrite this as like, okay, I have this xa is 0 plus 10 cos 30 multiplied t. Now you see, even though I started writing all those equations, say like this is my equation number 1, right? This is my equation number 2. Oh, never mind, that was not my intention. This is my equation number 1. This is my equation number 2. I was not able to solve any of them because I don't know the time t, right? So we're going to do something about that. So to do that, let's see if we have a means to do that. So what is the y value position at point C? 0. It's 0, right? So do you know the y equation? You do, right? It is the equation that everybody wrote at the beginning. So write that equation. Plug the value of, Alina got it? Write the y equation. Plug the value of y equal to 0, okay? Okay, you understand? Everybody understand what I'm saying? Say like the ball started from the 0 y location, right? It goes up, then come back to ground again. Ground y value is 0. So we're going to plug that 0, right? What's your goal? To find the time t. Time t of what, Joe? Time t for the ball to travel from one place to the final place, okay? Can you do that? Find the time t? I know exactly that's the thing you did in physics 1 lab, okay? Remember, when the ball is traveling, you're finding the value of the time, right? By putting the value of the y of 0. Maybe you remember, maybe forgot. But here you'd be doing it again, okay? What you're doing again? The third equation, y equation. Remember the y equation you did? Write it, right? The y equation? Write that one again. So the y equation, y was equal y0 plus v0y t plus a t square half. That was the generic equation, right? Let me rewrite that. It was a little bit overriding. Half a t square. That was the generic equation. Now, to go with this problem, I would like to rewrite that. I mean, yc. You see, why did I write yc? Take a look here. This is my point C, and this is my point A, right? So that's why yc equal ya plus VAY. Why did I put VAY? My initial point was A, right? Minus half of, instead of A, I am putting G, right? Negative G multiplied by G squared. Now, we know YC is 0, right? Because why? The projectile hit ground, right? After time t. Everyone's with me so far? 100%. Perfect. So then you're going to start to plug the values. What is the value of YA? 0. It will be 0 again. Okay. What is the value of VAY? We don't know. We didn't find it, but we had the equation for that. Is that the thing? 10 sine 30. All right. Oh, I'm missing a time t here, by the way. See, I have a time t here, minus half of, 9.81, right? And the time t, do you know time t? No, we don't know that. All right. So, okay. And you may want to put some units here and there, but bottom line, the unit here is in meter, right? You understand that? After the time t and everything, I'm just skipping the unit for now. Okay, so then I'll have 0 equal this sine 30 is half, you know that, right? 10 divided by half is 5, so 5t, okay, minus this 9.81. If you're going to divide it by 2, it would be 4.9, right? 4.905 if you're not consider the 1 as well, and then t squared. Now this t, let me rewrite that, 4.905 t squared equal to 0. Now that's the algebra. Let's see if you remember. The t is common, right, in both terms. So can I write this t and then 5 minus 4.905 t equal to 0. Can I write the last line? So that tells me what? The value of the t could be either 0, or you got to have that equation for that, like 5 minus 4.905 t, right? Which is like, if you're going to rearrange things, t would become t equal 5 divided by 4.903. Basically, it means 1 point something second, right? Now, the question is, we're trying to find the time, right? If it's time t equal to 0, is it a correct answer? No way, right? So that then the ball is not traveling. If the ball travels actually from point A to point C, that means there is a time involved, right? So that 0 result for t is not applicable, right? So the other result of the t, that is applicable, and you would be finding that. So obviously, as I'm saying, it could be 0 second or 5 minus 4.905 t equal to t, and you're going to find the t value by doing the math. 4.905, which would be 1.019 second, right? It could be this or this or this. Obviously, this is not the answer, right? This is the answer. Okay, I'm taking out the question mark. So I'm putting this thing as like that's your answer for time. Now, what is that we're trying to find? Few things, right? The velocity and the x values. Now, take a look on equation number 2. If you know the time, can you find the x? Like, how much of the distance that it can travel, right? 52, right? You do that? Let me do that because we are running out of time. So I'd like to finish it with the time as well. So you see, you'll be using equation number 2. Okay, so equation number 2, and plug time t, and then you're gonna have obviously xc equal 10 cos 30 multiplied by time t, right? It's good so far? All right, what are you going to do then? You'll simply plug the values, right? So you will have this 10 cos 30, which is, by the way, 8 point something, 8.7. I'm not writing it. I'm writing all together. So I have this 1.1019, right? The whole thing would be in meter, right? And then I'm going to have 8.83 meter. That's my final answer, xc. That's one of the final answer. That's not all. What is the other thing? So you have to find this VCX and VCY. Okay. Now let's see how much you follow, how much you remember. So the final velocity at point C. Okay. Doing some time. So we're done. I'm gonna talk. I mean, we're at the very last moment. Okay. So don't worry. Like one of the things, remember the final velocity in x and y direction. One of the things you already know. Okay, which is VCX. Why? Remember, I said like the velocity in x direction doesn't change. Remember that? So VCX, do you know that, right? Yep. VCX? Okay, so VCY, how do you find it? Do you know the equations for VCY? we did write it like out of those 4 equations, one equation is for Vy. Remember that? One equation is Vy, right, Joe? So you'll just use that one to find that. Is it good? All right. So I'm saying like, okay, you have this Vcx equal to same as like Vax or V0, right? V0x, whatever symbol you want to use. That is 10 cos 30, which would be 8.66 meter per second, right? Now Vcy, you know that equation, which is Vay minus gt. Now you may get confused with this equation, right? Which came from, you guys remember the generic equation? It came from what equation? Vy, that's the equation you do right? Equal what? V0y plus a multiplied t. Is that the equation you wrote? So did you see why I wrote minus g instead of a? A acceleration is actually negative g, right? That is you know that, right? Acceleration is negative g direction. Okay, and Vay is it's just A and C is just the location, right? So that's my initial location. The projectile goes from A to C. That's my final location, okay? So this is actually equivalent to 0. You understand that? All right, so now that you understand all the symbols and everything, don't get scared by seeing the symbols, okay? People use all sorts of symbols based on that particular problem that they're dealing with. All right? So Logan, you get the final result? Yeah. Okay, what is the final result you found? Is it 10 meter per second, the total velocity? You did the Pythagorean, I'm assuming, right? So 9.81 multiplied 1 point, remember the time value was 1.019. You remember that? I'm plugging all the values, and obviously everything would be in meter per second, and I'm gonna come up with the value of -5 meter per second. That my Vcy. Okay, and the V would be what? Vcx square plus Vcy square. Right? The Pythagorean, we always do that, right? Pythagorean in x and y direction is square root. And then we have this 8.66 square minus 5 square. If you do the math, you're going to come up with a value of 10 meter per second. And that's the value at C. And that's the final answer, okay? I know I'm running out of time, but still, let me give you a quick overview. Is that value everybody found? Yeah. Okay, so I'm giving you a quick overview. Again, it all started from 4 equations that I wrote for the tab, okay? And here's the catch, just a highlight, okay? Remember that. The x direction velocity doesn't change, okay? When it starts, when it ends, at any point when it is flying. If you remember that. The gravity is my acceleration and it's acting downward, okay? So those are the things you need to know, okay? Once you know that, then depending on what is given, what is not given, in this case, like the time was not given, right? You got to find the time first, okay? And easiest way to find the time, if you know the y final location. It is falling into ground again, that's the 0. Start from 0 again. So 2y you know, right? So that was the thing used to find the value of the time. You understand? Once you have the time, you just have to plug the time value for all other equations, like the x equations, y equation, vy equation, whatever you want to say, right? Every student confident with projectile problem? Okay, perfect. Do the math.